generative AI and mobile application development are not two things that you tend to think about together. Today, we are here to talk about the intersection of these two worlds and to talk about how this phenomena of generative AI is going to meaningfully intersect our world of mobile software application development and, in the process, make us better engineers and help us build better products. I'm Mohsen Agsen. I've been at Meta for 7.5 years. I have worked on messaging products, mobile applications, and I've worked on AI products, including generative AI. And it's my pleasure to take you on this journey with us today. You've probably heard about generative AI. I assume everyone has heard about it for now. And I think there's many ways for us to think about it. We draw it as a cross, a kind of fork in the road, but we can think about it in a few different ways. We can just ignore it, assume it's not relevant. It's kind of the server thing. We can think about it as a threat and get hyped up about like a lot of the safety concerns, a lot of the job debate. We'll talk about that. Or we can think about it as an opportunity. I think we are here to talk about it as an opportunity. We will be respectful and aware of its challenges, and we will discuss those as well. So we will apply learnings from our own organization at Meta so that we all, as mobile engineers, can use generative AI in an effective way to move to the future. Our industry has had a great deal of paradigm shifts over the last 50 or 60 years since the invention of computers. We've seen large computers and taking floors and going all the way down to being in our pockets or in our ears. We've seen the rise of the internet, redefining what software is. And these paradigm shifts bring a lot of uncertainty and a lot of change. We believe we're at the beginning of one of these paradigm shifts, and we believe it is powered by generative AI. And we believe that it will lead to kind of a new ways for us to interact with computers, with technology, and also it will lead to new ways for us to think about our careers as software engineers. So what's generative AI? Well, the story started with transformers. Transformers are, a branch of deep learning networks, and they are trained on very large amounts of data. These transformers effectively, they read a lot of data and they figure out relationships between things, between words, between sentences, between contexts. And as a result, they have an emergent ability to be able to complete what you give them and effectively attempt to use their knowledge, use that training, use that network to, I'm going to use the word invent. We will talk about that in a little bit more, invent or generate the remaining context. We will see examples of that. So they've been used very effectively in things like translation models. As a matter of fact, that was the initial use case for generative AI. They've been used in image generation. You sometimes will hear about those being talked about as diffusion models. The flagship of transformers are probably so-called large language models. These are specific types of transformers that are trained on trillions of tokens. And these are the ones that do precisely what I just described. They read an enormous amount of text. And you're able to give them a small amount of text, and they're able to take that text and effectively complete it, generate what comes next. They could be fairly brilliant at creating content. They can create a lot of different things. With a small piece of text, you can have a large language model create emails or stories or comments. Their siblings, the image models, can take a small piece of text and generate an entire image, an entire scene. They can generate a sticker. We will talk about that when we talk about meta launches. In the example here, we talk about a very small sentence of telling the language model, generate a Python program for A-star pathfinding. And what you saw is the language model produced the Python code and produced test code. Now, it's easy to assume it just memorized that. It just saw that exact question with the exact response. Well, if you ask the language model to try it differently or to structure the code differently or to produce different tests, you will see that the result is very different with the same exact result. What you're seeing is I'm capturing an intent with text. The language model is trying to satisfy that intent, in this particular case, by producing code, by producing tests. So you can now start thinking about them as kind of these universal computers, effectively. You can think about them as intent-based computers, if you wish. In the example here, we use a few examples to get the language model to think about itself as a classifier of sentiment. So you give it an example, a positive example, a negative example, and kind of you get it to try and guess what should be the next example, and you will see that it was effective. At least based on that pattern, it probably matches the intuition of most humans of, okay, well, that probably means neutral. It's not clear which way you classify. So language models are not things you always just give text in and get text out. Sometimes you can instruct them, and actually I would say often, as software engineers, you will instruct them in a way where you take user input, you'll do some work on it, you give it to the language model, and you instruct the language model to give you some structured data. They might give you SQL queries. They might give you JSON data. They might give you YAML data. They might call APIs that you implement. You process them. You may take the results and produce user experience, or you may take the result and give it back to the language model. We will discuss that in a few examples later on. But fundamentally, they are still text in, text out, although you can play these tricks to get them to give you different kinds of text, structured text, that you can take real structured actions with. While they're amazing generators of content, large language models do have challenges. One of the challenges is their training cutoff. They are trained by information up to a certain point. They do not have a built-in ability to get real-time information. And that severely limits them. In the example we show, that's a language model that was asked about stock price. You can ask it about weather. You might have internal data. It has no idea what these things are. It was not trained with them. It was not fine-tuned with them. So it doesn't have access to that data. So that's one of the challenges. The more serious challenge is because they're such effective creators, they're generators after all, when they don't know the answer, sometimes they'll just invent an answer. And as a result, they can appear to hallucinate. They can appear to have flawed logic. The example here, we show it as an example where most people would figure it out pretty quickly. And a very advanced large language model might struggle with that. So now you can look at these language models and you can say, well, you can dismiss them. What's the value of something that I guess is kind of interesting, can generate content, and it doesn't have access to real-time information, and it can invent stuff. Does that mean it is only limited to creative writing, creative use cases? I don't think so. And I think it's very important that we do not underestimate them. It's important that we don't dismiss them as, well, they're just for creative writing. They're not really for real software. The reason is simple. The industry is fixing these problems. People are clever. And the industry keeps figuring out solutions to these problems. The problem of hallucination can be mitigated, can be addressed through a very large number of techniques. I'm not going to talk about the very advanced ones like fine-tuning, etc. But instruction prompting and picking very specific instructions to manage the language model and have it to produce the output that you desire, giving it examples seems to make a difference. Sometimes asking it to question itself and review its process dramatically improves its reasoning ability. On the up-to-date information side, we've learned how to get the language model to say, I don't have that data. I'm going to tell you I don't have that data, what I need, and you give it to me. And then you can. So effectively, you give the language model text, it comes back to you as something structured. You go execute, and you give it the data, and then it responds. You will hear these things called about as different patterns. You hear them talk about as tools, plugins, functions, retrievers. They're all in the same vein. They're all ways for software systems to augment large language models, enable them to have access to real-time information. At Connect last week, I believe, or the week before, we introduced Meta AI, and Meta AI has the ability to search the web. And the way Meta AI does that, it knows when it takes a user request whether it has the knowledge to satisfy it. And when it doesn't, it talks to us, and we talk to a search engine, we get the results, we give it to the language model, and the language model responds. So let's not assume that all is lost, that these large language models are just creative writing tools, clever, haiku generators, and things like that. They are far more capable than that, and the industry is working hard to address them. Now you can also flip to the other side, saying, oh my God, okay, well, they can create code. We're fixing precision. We're giving them access to real-time information. And because of that, you can start thinking about them as a threat. You can think about them as a safety threat, and you can think about them as a job security threat. From a safety perspective, we'll talk about that more. From a job security perspective, if these things can actually code and debug and profile and analyze logs and do a lot of things that we do, could they take away our jobs as software engineers? I think we're here to say no. All of us, not just myself. If you think about senior engineers in the industry, they tend to write less code. They tend to look for harder problems, and they tend not to take on a lot of the manual coding tasks. They leave that to more junior engineers. So one way to think about the arrival of AI and large language models and generative AI into the world of software development is, instead of a replacement for software engineers, we should think about that as an accelerator for software engineers. It just accelerates our tenure more rapidly because it can take on a lot of the tasks that used to take us time and used to take us a lot of learning. And instead of thinking about them taking our jobs, they're more of an opportunity for us to up-level our jobs. Let's solve bigger problems. Let's solve harder problems. Let's think about, again, a lot of what senior engineers do in organizations. They think about processes. They think about architecture. They think about algorithms. They think about code. They think about the structure of systems. They think about, testing. They think about experience. They become more multidimensional. And I think the arrival of AI as an assistive technology in coding should accelerate all of us into that tenure. So as programmers, we finally are getting something that we've always wanted. We're getting a programming assistant. And we've talked about this actually for decades, about the dream of having the tools and the systems we use understand our intent and help us in more fundamental ways. We have been on this journey, and generative AI could be the pinnacle or like the beginning of a dramatic shift in that journey. We now have generative AI models that are specializing in code generation, help us produce better code. Code Llama, released by us a few weeks back, released by Meta, is a great example of that. Some of you might have used GitHub Copilot. Some of you might have used OpenAI to generate code. They can do more than just generate code. The AI can play an adversarial role with you. Maybe you write the code and the AI can write the tests, or you write the code and the AI writes the tests. It can help you figure things out. If you're seeing cryptic error messages and you can't figure out, you could probably paste the code and the error message, and the AI could be almost like having another programmer, a fresh pair of eyes to look at things and help you. So I think a great way for us to approach the generative AI problem from a software development perspective is to think about us as software engineers being challenged to up-level our skills and have an amazing set of tools now that can truly make our experience more effective and more productive. So it is an opportunity for us to be better software engineers. Equally, if not more importantly, it can help us build better products. The world of software always evolves in complexity, and a task as simple as scheduling an appointment becomes a very large set of UI experiences. Those of you who've gone through like settings in products or privacy, or again, we use an example of scheduling an appointment, the amount of user experience that we have to develop, we have to refine, and the user has to interact with is quite large. And I think that's there with reason. It probably will be there for a long time with reason, but we can augment it and offer users an easier way to interact with these complex forms. So maybe instead of the user clicking every button and filling out every form, they have the option to say a sentence and have the AI fill out the form for the user to then complete the task. And maybe in more advanced universe, the AI can actually complete the task. So it is probably easier to say, schedule a team meeting on Wednesday at 2 p.m. Let's repeat that every 3 weeks, except on, if it overlaps with something. And remind me 15 minutes before. And it can fill out the form for a user, and the user can just submit it. In addition, it can help us build products that require less screen time. Some products demand screen time. They deserve it. They're entertainment products, etc. Some products we at least have the option to allow the user to look away from the screen and still use our product, interact with our technology. They might be able to talk to our software, and our software might be able to talk back to the user. That's another kind of opportunity that large language models and AIs can play a role in our applications. Not taking away the screen, maybe reducing the screen and playing a complementary role. Insight is a tricky topic that we struggle with often. We help users with onboarding and with tooltips and with tutorials and with walkthroughs and with external documentation and with all sorts of guidance and like YouTube videos and all sorts of things. And they will always be with us, but the AI can come and play and kind of a complementary role to all that world and help software teach the user, suggest to the user what to do next, have an additional insight on what the user, help the user onboard, help the user make some changes that might not be very obvious or very intuitive for most people. So AI can help make us better engineers, and it can help us build better products. Let's talk about these large language models and where we get them and how we use them. I will talk about Llama 2 as I am of Meta. Large language models come in a variety of sizes and flavors. Generally, smaller models tend to be cheaper to operate and run faster. So the inference speed, when the time you give it text, the time you get text back is going to be faster. And therefore, it tends to be cheaper. You're using less GPUs. Their quality might not be as good. And quality is a subjective measure. You're going to have to decide what you mean by quality. It might mean the brevity of the response if you want the AI to respond in a concise way. It might be the tone of the response. It might be the sentiment that it actually classified based on your request. It might be the task that it had to do if it was an assistant supposed to produce an API call that performed a particular task. In general, you will find that the larger models are more capable in quality without having to do advanced machine learning techniques like fine-tuning. Smaller models are less capable, but are cheaper. So you will have to learn and you'll have to experiment to figure out what works and what doesn't work for your domain. In terms of actually integrating with them, nothing could be simpler. If assuming that you have a hosted version of one of these large language models, you're probably going to be dealing with usually one or two very simple APIs. You give the model a piece of text and it gives you back text. This is what we call a text completion. You see the example here, the color of the sky is, and it's going to complete it with blue. Actually, if you try this on some language models, you will see that it's answering with a lot more than blue. We will talk about that a little bit. The second topic is you can use them in what we call chat completion. Chat completion is like a more sophisticated version of text completion where you role play with the AI. You give it examples of what the user would say and how it should respond, and then you give it user input and then it responds. So it's a lot more commonly used in what we call chatbots, in what everyone calls chatbots. So text completion completes sentences. Chat completion gives you a more interactive experience between you and the AI, but it literally couldn't be simpler than that. They're very, very simple systems. They're complex on the inside. They're very simple on the outside. So now you can say, well, okay, well, they're very easy. I'm just going to go right to it and I want to do it. Well, hold on. Just be careful. Let's go back to the topic of safety. These are very powerful systems. These are systems that have read an enormous amount of content, have learned a lot of things, and not a single human has read every single thing they've read and curated it and double-checked it. So they're also prone to hallucination. So it's very important that you take safety in mind. So you have to basically watch out for users potentially exploiting these models and getting them to do things or answer things they should not be answering. You have to watch out for the model either hallucinating or leaking information out of its knowledge that you really don't want to expose to your users. And you also really want to watch out if the language model is going to give you structured data that you're going to act upon, an API call, a database query. You have to be really careful with these things. Those do raise legitimate safety concerns. When we released Llama 2, we released two documents. One is a research paper that talked a lot about what we did for safety in these Llama models. The second one was we created a responsible use guide. I strongly encourage you to explore both because they talk a lot about this topic, how you validate input, how you validate output, how you protect your systems when you integrate AI into them. These are possible. A lot of companies are doing that, and I encourage you to consider that. Token limits and context window is just a quick reminder that language models are effectively stateless servers. You give them data and they give you output and they do not remember. You have to give them more data for them to remember and more data for them to remember. And eventually they run out of what we call a context window. So you have to look online, you have to read, you have to learn how you can address these limitations of memory and context window. You can be effective if you've seen examples of some of the chatbots, and we'll talk about a couple of them in a minute. They have the illusion of memory, and they actually have some memory, and we will talk about that briefly. So at Meta, we have obviously embraced this phenomena. Many years ago, I was drawn to Meta because it was a flagship AI company, and I'm proud to say that we've continued to be a flagship AI company. We have embraced the generative AI paradigm shift wholeheartedly. We have released these world-class models. We have released these world-class code generation models. And a couple of weeks back, we released a suite of enhancements to our products that are all AI-powered. We are giving our users the ability to not just consume stickers, but create stickers by using creative language models or creative diffusion models. We've given them the ability to produce images by imagining things typing in text and having our AIs give them images that they can share with chat members and friends and family. We've given them a Meta AI assistant, which is a general purpose AI that can almost is open-ended. You can use it for anything. And that AI assistant has access to search, so it's able to get real-time information. It has a tremendous amount of knowledge and memory. You can ask it questions. You can ask it about real-time information, about historical information, about insight. You can give it instructions. You can ask it kind of to do things or of how to do things, and it can teach you how to do things. And finally, we've created these very interesting AI characters that we put into our products that can help people with travel, with cooking, with advice, with entertainment, with gaming, with sports, with health, with all sorts of things. You're seeing the beginning of us now starting to use AI in an effective way to build better products. This is all an external view, and you're seeing Meta take generative AI very seriously, both from a model perspective as well as a product perspective. But I'm here to also tell you we've taken it to heart also internally. We are big believers in the power of generative AI to help us all be better engineers, to help us be more productive, to have higher quality software, faster time to market, less issues. We're not spending time thinking about whether it's going to replace us or not. We're spending more time thinking about how it can make us better, how it can empower us to be better engineers. And we're all, like everyone else, we're all still early in that journey, but we're fairly confident generative AI is going to play a very key role in our ability to perform as software engineers in the future. So with all of that in mind, I would strongly encourage you to think about the paradigm. Do not ignore generative AI. Do not dismiss it as a gimmick, but also don't just plug it in and just YOLO. Think about a thoughtful, responsible way for you to use it in your products, improving your products and your experiences. Also, please do not just simply dismiss it as a job threat, and think of it more as the next generation of tools that can help you, help all of us be better engineers. And I do think that generative AI will be with us for quite a while. So we might as well all go on this journey together and grow together and enjoy the process. Thank you very much.